right, guys. Sorry I'm not here for you all today. I'm at the coaching a soccer game at the middle school, St. Clair Walker. And I want to make sure you guys have the material, and this is the best way I know how to do it. So here we go. First thing we're going to do is we're going to look at our radicals, okay? We're going to learn how to simplify radical numbers. So the first thing is, let's look at what a radical is. This whole thing is a radical, okay? So if we're talking about radical numbers, we're talking about numbers that have the check mark, which we call a square root, and a number, okay? Those are called radical numbers. Now, if we were to dissect it a little bit more, this number inside, just the number inside of the radical, is known as a radicand. Okay? So you have a radical and a radicand. Okay? So those are the two terms you're going to use a lot. You're going to certainly use square root. The check mark is a square root. Okay, so this time what I want you to do is on page 14, I want you to write radicals, and I want you to write what a radical is, what a radicand is, and remind yourself what a square root is. Okay? So go ahead and write that down. The next thing I want to talk about is simplifying radical numbers, okay? What you have to do is called prime factorization. Okay? And what we're going to do later this year is we're actually going to play a game called Prime Climb. Okay? In Prime Climb, we're going to really dig into more of what a prime number is, and all of the prime numbers from 2 all the way up to 101. Okay, but right now we're not going to do that right now, but there's lots of prime numbers. And what is a prime number? So a prime number, so you need to have prime factorization written down. We're still on page 14. And a prime number is any number with only 2 variables. As you were, only 2 factors. I apologize. Okay? So a prime number is any number with only 2 factors. So, for example, 0 has infinite factors. 1 has infinite factors. So you have 1 times 1 is only 1 factor, okay? So what we're going to start with is the number 2. The only factors of 2 are 2 and 1. 2 times 1 is 2, and 1 times 2 is 2, and there's no other way to do it, okay? So let's have some examples of prime numbers, and these are going to be important. So you're going to have 2. The number 3 is a prime number. You have 3 times 1, 1 times 3, that's only 2 factors. 3 is a prime number. 4 times 1, 1 times 4, but you have 2 times 2, so that does not work. 4 is not a prime number. In fact, the only even prime number is the number 2. All right? The number 5. Number 5 is a prime number. 1 times 5. 5 times 1, those are your only factors, so you have 5. 6 and 1, 1 and 6, but then you have 2 and 3, so that does not work. You also have the number 7, okay? So now we know even numbers don't work. How about the number 9? 9, you have 1 and 9, 9 times 1, and then 3 times 3, so that's not a prime number either. 10 we know isn't because it's even. How about 11? 11 times 1, 1 times 11, there aren't any others, okay? These are the 5 I want you to memorize. 2, 3, 5, 7, and 11. Okay? Now, when we get going and we learn how to play this game, you're going to realize there's a lot more prime numbers than those 5. Other prime numbers would be 2, 3, 5, 7, 11, 13, 17, 19, 23, 29, 31, 37, 41, 43, 47, 53, 59, 61, 67, 71, 73, 79, 83, 89, 97, and 101. So everything in here that's red is a prime number, okay? And I'll tell you how to play that game at a later date, but the 5 we really want to know when we're simplifying radicals is 2, 3, 5, 7, and 11. If they aren't one of those factors, you probably aren't going to be able to simplify it unless it's just straight out a prime number, which with those numbers we'll be able to find out as well. Okay, so still on page 14, I want you to write simplify radicals. Examples. Okay? Now, not every number, so let's look at the square root of 9. So this is example number 1. I'll probably give you 5. Example number 1 is 9. Okay? So let's look at 9. So again, we're going to look at our numbers 2, 3, 5, 7, and 11. Those are going to be very important numbers for you to remember when you're doing this. Okay, so let's look at the number 9. The number 9, if we factor it, 2 does not work. 2 times 2 is 4, 2 times 3 is 6, 2 times 4 is 8, 10, so that doesn't work. But 3 does. 9 is going to be 3 times 3. Both of these are prime numbers, and there are 2 of them. Now, the way that I look at this sign, as I look at it like a washing machine, okay? And growing up, my mother used to always tell me that the laundry machine ate my socks, okay? And when I was young, we always wore matching socks. And I know it's really in vogue right now to not wear matching socks. My daughter doesn't wear matching socks. But for the debate of what we're doing, let's assume we always wear matching socks. Now, we're going to look at the numbers we circled. 3 and 3 are both the same. It's the same sock. Socks come in pairs, but 2 socks is 1 pair of socks. So what we're going to do is these 3's are going to come out, and I get the number 3. Let's look at the 9 differently. 9 as a square root is perfect. It is a perfect square. 9 is a perfect square. I have 1, 2, 3, 4, 5, 6, 7, 8, 9 blocks here, and it makes a perfect square. That's why it became 3. They're not all going to be perfect like that. I wanted to start you with a perfect one and then work my way up. All right, let's do a new one. Number 2. If you're still on page 14, that would be great if we can get all this stuff on page 14 in a legible way. Okay, because if we quiz on it, I'll probably let you use your notes. All right, now we're going to have the square root. Let's try a new number. Let's try, I don't know, the number 20. Okay, the number 20 is a pretty common one. Now, what I'm going to do is I'm going to prime factor the number 20. Okay? Because number 20 could also be written, I'll just keep it in black. I'm going to start with 2, 3, 5, 7, and 11, and I'm just dividing into it. 2, 20 is an even number, so I know 2 will go into it. All right? So I have 2, and I have 10. 2 times 10 is 20. Okay? So that totally works. Now, 2 is a prime number, so I'm going to circle it. Okay? Now, second We have a 10. 10 is also an even number, so I can use 2 again. So I'm going to have 2 times 5. Both of those are prime numbers. Okay? Now, here's where the tricky part comes in. Remember my washing machine? I have to wear socks that match, right? So, now I'm going to look on this, and I'm going to say I have these 2 socks, they match, but I'm missing the match to 5. Okay? So the only things I can pull out are my pairs of socks that have a match. So I have a pair of 2s, so that comes out. The 5 is going to stay in the washer until I get a match. So it's 5 square root of 2. All right? So let's do another one, and we'll do a little bit bigger number. All right? The numbers, it doesn't get any harder. It just gets, you get going with bigger numbers. And then I'm going to show you that some of you might not always think of it like I do when I'm just having everything all the time. Having it meaning I divide by 2. So let's go to number 3. So number 3, I'm going to throw up a really big number. Let's put up the number, I don't know, 72. The square root of 72. 72 is an even number. Okay? So I'm going to look at it. I look at my 2, 3, 5, 7, 11. 2 will work. So I'm going to divide 72 in half. Okay? And I know you guys got that well before I did. But 72, half of 72, as you guys already know, is 36. Okay? Half of 72 is 36. Well, that's awesome because 36 is also an even number. So I'm going to divide that into 2. 2 goes into 36. Well, I know 2 times 10 is 20. And 2 times 20 is 40. So it's between 10 and 20. And I know that it's 18. Okay? Now, what you guys are going to find is those of you that struggle multiplying and dividing, this is going to be a very difficult task for you guys to break some of these things down. Okay? And now, from 18, I can do 2 times 9, and 9 breaks into 3 times 3. Now, I always use the small number. I go from 2 to 3 to 5 to 7 to 11. Okay, and I'm going to do this exact same problem differently in 1 second. Because some of you might not have known half of 2 was 36, and that would have thrown you off completely. And there's a way you could have done it. So let me just finish this first, though. So now I'm looking for my pairs of socks. Okay, there's 5 socks in my washer, and 2 of them match. I have 2 2s that match, and I have 2 3s that match. Okay, so I'm going to take my 2 out of the washer. I have a 2 sock, and I have a 3 sock. Okay, and still hidden deep within the crevices of the washer is the other number 2. I've taken a 2 and a 3 out, and because they're out of my washer now, that is going to be 6 square root of 2. You just multiply what comes out if there's more than one thing outside of it. All right? But let's say for number 3, you did not know what half of 72 was, but you did know something else. Let's say we're back to this 72. Okay? You didn't know half of it was 36, but you did know that 8 times 9 was 72. That can help too. 8 times 9 is 72 would also help. So instead of breaking everything down into 2s and only using one side of the tree, you're going to use 2 sides of the tree. So now you're going to have 2 times 4 and 4 times 2 times 2. And 9 breaks into 3 times 3. So at 72 you have 8. 8 is 2 times 4. And 4 breaks down to 2 times 2. Now, the only thing I don't like about this way is sometimes the numbers get kind of lost within what you're doing. And then sometimes you make mistakes. Somebody today said 4 and 4 was 8, but really that's 16. So don't make those mistakes. You have to know how to multiply. To check it, you would know that 2 times 2 times 2 times 3 times 3 is in fact 72. So if you ever want to just check your numbers, you can just multiply all your numbers together. They're all going to be single digits numbers. So you have 3 2s, so now you have 1 2 set of 2, 1 set of 3, that comes out, and the 2 stays in. So you got the exact same answer. You again got 6 square root of 2, and that's exactly what should happen every time. All right, so we've done 3. You've seen now that you can do it different ways, okay? And we're going to continue on this journey. Okay, last one that we are going to do is number 4. Hopefully you guys have room. If you don't, you know, we will live with you flipping over page 14 and putting it on the back. But ideally, make it legible. The most important thing is that you can read it, okay? So, number 4. Number 4, what you're going to do is I'm going to give you a big number. I'm going to do the square root of 171. Okay, we did this in my last class. 171 is a tough number. 2 does not work with 171. So again, I'm going to look at my numbers. 2, 3, 5, 7, 11. 2 did not work. Okay? Now let's move on to 3. How do I know if something's a multiple of 3, you ask? Well, all multiples of 3 have a trick to them. And that is if you add their digits, they also are a multiple of 3. So let me give you some examples. So multiples of 3 trick. Dun, dun, dun. The multiple of 3's trick. For example, a multiple of 3 would be 27. You guys know 27 is multiple of 3. If I were to say 2 plus 7 equals 9, 9 is also a multiple of 3. It's another multiple of 3. How about the number 39? I know 39 is multiple of 3. So I have 3 plus 9 equals 12. 12, in fact, is a multiple of 3. Now, it does not always mean that 3 times 9 is 27 or 3 times 12 is 39, okay? Because 3 times 12 is only 36. So this isn't telling you what the answer is. It's just a trick to tell you that they are, in fact, multiples of 3. So let's do another bigger one. How about like 87? 8 plus 7 equals 15. 15 is a multiple of 3, so 87 also is a multiple of 3. Now, let's go back to number 171. 171. Now I'm going to do 1 plus 7 plus 1 equals 9. 9 is, in fact, a multiple of 3. Therefore, 171 also is a multiple of 3. Now, I've got to do this long-hated tradition of long division here. Single digit long division. 3 divided by 171. 3 goes into that 5 times. 17 minus 15 is 2. Drop your 1. And that gives me 57. Okay? So, when I'm dividing this down, I can do 3 and 57. Now, 57, is that a multiple of 3? Let's look. 5 and 7. 5 plus 7 equals 12. All of these have checked out to be multiples of 3. Now, the nice thing about 57 is it's 1 away from 3 times 20. Because 3 times 20 is 60. So I know this one has to be 3 times 19. How about 19? Is 19 a multiple of 3? 19 equals 1 plus 9 equals 10. That is not a multiple of 3. It's also not a multiple of 2, 5, 7, or 11, because 19 is in fact a prime number. Okay? So that leaves us with a pair of 3's that can come out, and the 19 stays in. So 3 square root of 19. Now, the final one I'm going to do, number 5, I'm actually going to have a number already on the outside. Okay? So just in case y'all didn't get that. 171 is 3 times 57, 3 times 19, 3 square root of 19. And that's just the 3's trick. So, number 5, last one. Again, if you have to go on the back of page 14, that's okay. I know the next 2 days will be a little weird with me on video. So, number 5, I'm going to put a number on the outside to start. So I'm going to have a 2 square root, and then let me get a really odd number. Let's do the number, I don't know, 65. Let's not do 65, actually. Let's do the number 80. Okay? 80. 2 square root of 80. So now what I'm going to do is I'm just really going to focus on this. I'm going to keep doing the same thing. 2, 3, 5, 7, and 11. Okay? 2, 3, 5, 7, 11. 2 goes into 80 40 times. Now, some of you might have said that 8 times 10 was 80, and that totally works too. You can do that. But I'm going to keep doing it my way. 2, and then 2 goes into 42 times 20. 2 goes into 20 10 times, and then 2 times 5. And again, those of you that multiply really fast absolutely could have done 10 times 8, and 10 is 5 times 2, and 8 is 2 times 2 times 2. You would have ended up with 4 2's and a 5. No matter how you did it, you should end up with 4 2's and a 5 as your prime numbers. So now we are simply going to look at what comes out. You get a 2 that comes out, another set of 2's that come out, but your 5 is stuck in the washer. You don't get to take the 5 out because it's not a matching sock. So now, you already had a 2 out there, so you already started with a 2 on the outside. And now you're going to multiply it by this set of 2's and this set of 2's, and it's going to be the square root of 5, okay, because the 5 stays in. So I made that 2 green because we started with that 2, so don't forget about him. 2 times 2 is 4, 4 times 2 is 8, so it's 8 square root of 5. All right, so that should give you guys a really good start on how we're doing this today. Other thing I want you guys to know, we did move our test back. I've decided to move it back to Wednesday, October the 3rd. And the final thing I want you to understand is that today, when we break into groups, we're going to do IXL. In one of the groups, you're going to do section V, and you're going to do section EE. And those are in the back of the room. They've already been written up. It tells you exactly what they are. If you're having problems in IXL, go to a station that you know so that you can successfully do it. All right? We're also going to have Kushball up on the board to keep working on exponents. We're going to have math libs going with our radicals, and then we're going to have IXL going so that, you know, when we break you guys up into 3 groups of about 5, I think there's about 15 of you in class. So have a wonderful day. I'm sorry I wasn't here for you guys today, but hopefully this will help you understand what you need to do to be successful on this test that we have coming up. Have a great day, and I will see you guys tomorrow.